Hello everyone. I am Prashant along with my team colleague Sarai. We are welcome you all in this new beginning. We are happy to announce that with the support of Open Science Community Twente, uh, we are uh, we are started new chapter, which is a student initiative for Open Science Twente. Before proceeding further, I would like to introduce our Open Science Officer, Dr. Marcus Cornell, who is currently Open Science Officer at ITC, University of Twente. Although as he always advocates about open science, but his major work is in about data reproducibility. He, he is going to talk about the meaning of open science and how it helps to a student. Please, Marcus, all yours.
All right, so let's start. I will share my screen.
Sure.
So you should be able to see my screen now.
Yes.
Perfect. So hello everyone and nice to meet you. My name is Marcus Cornell. I'm the Open Science Officer at ITC, which is the Geoinformation faculty at the University of Twente in the Netherlands. My job is basically to help ITC make the transition towards open science. I help individual researchers adhere to open science requirements, for example, when publishing papers or writing grant proposals. I also try to raise awareness for open science, for example, by giving presentations, as I will do it in the next few minutes. So thanks a lot for the invitation, for the kickoff of the SIOS Twente community. Today, I would like to give you a brief introduction to open science and why this is relevant for you. Let's start with a quick example. Several researchers have developed vaccines against corona quicker than ever before. One of these vaccines is the Russian vaccine Sputnik V. Europe and the US had strong doubts and it did not trust the vaccine. Why is that? Certainly, ideological reasons play a role. It's probably the typical game between the East and the West. However, there are also science-based doubts. For example, the European Medical Agency, in short EMA or EMA, evaluates the data of the studies as they become available to decide if they approve or disapprove the vaccine. But the raw data was not available, which is why there were doubts whether the vaccine is as good as reported. In this article, the authors reported that they have made several requests to get the raw data, but these were not answered. The author of this article concluded that the only way for concerns over Sputnik V and other vaccines to be quelled is for the developers to publish full clinical study reports along with the raw data. Not only will this build confidence in COVID-19 vaccine, but it will pave the way for other developers to follow suit. And these doubts have consequences not only in science, but also in politics. One of the prime ministers in Germany wanted to buy Sputnik V, but then he stated, there was a lack of verifiable documents needed to approve Sputnik V. The developers need to submit these documents. We cannot take the risk to approve a vaccine that is not documented in a scientifically verifiable way. What do you think will happen if Sputnik V turns out to be a good vaccine? Will people take it or not? I fear that trust is lost and they will not take it, the people. What do we learn from that? Apparently, there's a strong connection between reporting scientific research in a transparent way and trust. Trust between researchers and other researchers, trust between researchers and politicians, and trust between researchers and society. Transparency increases trust, whereas non-transparency increases doubts. To make it even more problematic, non-transparency paves the way for fake news. Okay, clear, fair enough. You might think we are not working or studying in the medical sector. We are, for example, from the geosciences. The students at ITC, so at the Geo faculty at the University of Twente, will work on the following topics: disaster management, geo-health, urbanization, digitization, smart cities, governance. These are rather big topics and not specific to the geosciences. And even if you're not working or studying at ITC, you will encounter these since they address the so-called Sustainability Development Goals, a set of issues summarized by the United Nations that need to be tackled in the near future. All these topics are very interesting and important research topics and have a strong connection to society. This means if you want to make change, you need to create trust. And we learned that you can create trust through transparency. Otherwise, you might develop a good thing, as Sputnik V might be a good thing, but the people will not take it. And this falls under the overall topic of open science. Before I explain what open science means, let's take a brief look at how researchers actually work. I would like to introduce you to Amy. Amy is a climatologist. She observed that the number of snow days has changed in the last years. Because she is a very good researcher, she would like to find some evidence for her observation. So she decides to carry out an experiment. First, she defines a research question. How has the number of snow days evolved over time in the Netherlands? The next step is to find a way to answer the research question. To achieve that, she needs to design a study or an experiment. Afterwards, she collects data, for example, by taking measurements, or by looking for databases that have data on the number of snow days in the last years. Then she applies some statistical methods to the data and interprets the results. She also needs to decide where to store the data and the analysis. Once she is done with analyzing the results, she summarizes all her work in a report. In science, we speak about scientific papers, scientific articles, or scientific publications. And this paper is what she is going to submit for peer review to a scientific journal or conference. Peer review means that other experts from her area read the paper and evaluate if the results are sound and valid. Simply speaking, a peer review can have two different outcomes. A paper can be rejected, which means that Amy needs to spend some additional work to address the suggestions, comments, and questions made by the reviewers. Or the paper gets accepted, which means it can be published. You can imagine that this is a very nice moment in every researcher's career. Unfortunately, there is a strong pressure in science to publish papers. In a traditional research system, a publication is the most important output. As you can imagine, this creates a strong focus on scientific articles. And researchers invest a lot of time in publishing papers, but not so much in publishing the data and the analysis. But these materials can be of great value for other researchers. For example, Ben. Ben is also a climatologist and wonders if the number of snow days has decreased as Amy found out. Has the number of raining days increased? To answer this research question, he needs to apply the same statistical method because he wants to answer a very similar research question. He could implement the analysis by himself, but wouldn't it be much nicer if he could simply access and reuse the analysis developed by Amy? This would save him a lot of time and also avoid duplication of efforts. He might want to find correlations between the number of snow days and the number of rain days. This requires access to the snow data collected by Amy. He could collect the snow data again by himself, but wouldn't it be much nicer if he could just access the data collected by Amy? Again, this would save him time and avoid duplication of efforts. So now that we know about the research process, let's briefly summarize the problems of missing data. First of all, finding errors in the research results is almost impossible if the data and the analysis are not available. All you have is a PDF document with text describing what was done and how. Second, reviewers cannot verify the results if the materials are not there. All they can do is to trust what is reported in a paper. And as we have seen at the beginning with the Sputnik V example, trust is not just granted. Third, it is pretty difficult to understand the study and the analysis if you cannot see the data. So the analysis might not be fully understandable. This is a problem during peer review, but also for those who would like to build up on the work. This brings me to the final issue. Not reproducible work is also not reusable. Other researchers need to start from scratch, which takes time and money. So this way of practicing research is not sustainable. And this is where open science comes to play. What is open science? Open science is an umbrella term comprising several practices to make the entire research process more open, transparent, and verifiable. Open access means that users gain full, immediate, and unrestricted access to scientific publications. Open data means that data is accessible in accordance with good data governance. Open software, code, or methods means that these materials are accessible under an open license. Open science or open source infrastructure is any kind of digital infrastructure needed to support open science. For example, platforms, repositories. Ideally, these platforms and repositories are non-profit. Open peer review means that the peer review process is transparent and the reviews are publicly available. Open education means that the learning materials should be freely and openly accessible, reusable, and redistributable. Then there's also open engagement of societal actors. So it's about involving people outside science, for example, citizen and participatory science. And finally, openness and diversity of knowledge system, which is important to recognize richness of diverse knowledge systems, holders, and producers. I personally like this definition a lot because it does not only focus on technical aspects, but it also considers societal issues. And as you can see, the focus is not only on the scientific article, but also on the other research components like data and code. In summary, open science is about giving value to the entire research process. In open science, there are also concepts that connect some of the open science principles. The problem is that there's often quite some confusion around terms. The Turing Way project provides a nice overview of existing terms and what they mean. Research results are reproducible if others can use the same analysis and the same data to produce the results from the paper. Results are replicable if others can use the same analysis for a different data set and achieve consistent results. Results are robust if others use the same data and a different analysis. And finally, results are generalizable if others use a different data set and a different analysis to answer the same research question. I'm pretty sure you will forget about these differences soon. I also do it, but I strongly recommend to look at these terms from time to time. And yeah, in science, it's very important to know what these terms mean and what the differences are. Let's look at the incentives of and benefits of open science. So in fact, open science can help researchers become successful scientists. They can collect more citations, they can pave the way for new collaborations, they can get media attention even if they want to. So just think about the corona crisis, how many researchers got media attention, and increase the chances to get funding. If you are a bit more into drama, open science can even save lives, which is one of the lessons learned from the COVID-19 pandemic. The sharing of data has helped to understand the virus quickly. Sharing results early also helped to do research in a more efficient way. Open science is also part of Shaping 2030. Shaping 2030 is the University of Twente's mission, vision, and strategy to increase the social impact of research as well as diversity and inclusion in science. So researchers at UT will also get formal recognition. Finally, also hiring practices seem to change. More and more job calls in academia include open science statements. This means that applicants need to show how they want to adhere to open science principles if they get the job. I'm speaking all the time about researchers, but you are students. You might not be interested in an academic position after you finished studying, and that's totally fine. Maybe you prefer taking a job in industry. Does that mean that open science is not relevant for you? Certainly not. It is relevant far beyond research. A very nice property of open science principles is that the underlying techniques are useful in other jobs as well. So data management, for example, it is important for open data and thus important for open science, but data management is also a fundamental skill of a data analyst working in a company. Open science is also about reusability, but also in a company, you are not going to work by yourself, but in a team. So the materials you are producing, for example, data sets and source code, should be reusable by your team members. Can you imagine a company that does not rely on software? This means that proper software skills are not only important to achieve open reproducible research. Also, companies can see your work and they might contact and hire you. If you want some recommendations, start with the following. So first of all, keep your workspace clean. I'm not speaking about your physical desk, but your computer. Take a few minutes to name files properly and create a comprehensive folder structure. I also strongly recommend learning a versioning software, for example, Git. Similarly important are scripting languages, for example, Python and R. I provided some links to some very nice and very well made tutorials. So we will share the slides later and you can check the links. Despite these, in my opinion, very strong incentives, we have an open science problem. In 2016, Monia Baker published a paper in Nature about reproducibility. She asked more than 1,500 researchers if there is a reproducibility crisis. Remember the definition of reproducibility: same code, same data. 38% said, yes, there is a slight crisis. 52% said, yes, there is even a significant crisis. So in total, 90% think it is impossible to achieve the same results by using the same code and data, which is quite an alarming number. And it is not only a problem in medicine, but also in chemistry, biology, physics, earth sciences, and probably in every discipline that relies on data. Why is that? There are several reasons. First of all, methods and data sets are often not available. Many researchers also lack the technical skills to publish open science. For this reason, teaching is one of the most important means to solve this issue. Ideally, it starts already on the student level. However, these skills are important at all stages of the research career, including early career researchers, senior researchers, and also department heads. We also see again the pressure to publish scientific articles. This in turn means that there's no pressure to publish data and code. But there are more reasons. First of all, many researchers fear losing their competitive advantage. What if others publish papers faster based on the materials that you made available? You could solve this issue by publishing the materials at the very end of the research process. Another possibility to solve this issue is to impose an embargo on the materials for 1 year or so. So you put the data online, you put an embargo on it, and for the next 1, 2, or 3 years, it will not be publicly available. But once this embargo expires, it will be made publicly available. Another problem is that preparing source code and data takes a lot of time. But is this really the case? It might also save you time, since it happens quite often that you need to redo the analysis. Anyway, you could just provide a bit of documentation, better provide the source code, as it is then not at all. Another issue is proprietary software, particularly point-and-click software. So the geo participants will likely know Esri software, for example, ArcGIS. And this is proprietary software. This can only be solved by using open source software, ideally scripting languages like R and Python. The way I presented these issues sounds a bit like it's the researchers' fault, but it's not. I don't want to blame researchers. I can even understand some of the concerns. The main problem is that they are part of a system that strongly relies on 3 problematic pillars. If researchers get evaluated, for example, when applying for a job, promotion, or tenure, then there's a strong focus on how many papers you have published, in which journals you have published the papers, and how many citations you have collected so far. As you can see, these metrics don't focus that much on if you have made your data and your source code or your analysis transparently available. So it is not surprising that many researchers think that reproducibility was not yet relevant for them. Why investing effort in something nobody is asking for? However, this will change. Let me tell you why and how. There are more and more initiatives that have open science on the agenda. The UNESCO released a recommendation draft on open science that requires publicly accessible materials. The European Open Science Cloud is the largest endeavor in Europe to create an infrastructure for sharing materials. The largest funding program in Europe, Horizon 2020, also provides guidelines for open access to papers and data. These initiatives are rather top-down, but there's also an increasing number of bottom-up initiatives. For example, reviewers start rejecting articles that do not provide access to the underlying materials. So taking our example, Amy would have failed to publish her article if she would not have provided access to the data and the analysis. And that's also reasonable. So how can they evaluate a paper if they cannot fully understand it? In the Netherlands, some researchers interested in open science teamed up to create so-called open science communities. These communities are bottom-up communities to learn, share, and discuss open science practices. One of the main goals is to make open science more visible and accessible by organizing events, seminars, and workshops. It's also about bringing people interested in open science together to facilitate knowledge exchange amongst peers. Members can also start their own initiatives around open science, and these communities are open to everyone. So we are not an expert club. You don't need any expertise, it's just about curiosity. Members can ask questions, look for support, share experiences, and gain skills. I am co-organizing the open science community in Twente together with Professor Raul Sotritamila, who is the professor from the Department for Geoinformation Processing, and Marga Köhlen, who is in charge for everything related to data management and ethics. As you can see, there are also several other open science communities in the Netherlands and also outside the Netherlands, and we are also connected. We also have a website, so feel free to visit it. You can become a member of the community, which means that you will get regular updates about events and materials. And we also have a newsletter. And we also organize monthly events, so-called Open Science Kitchen, where we present and discuss topics around open science. Just become a member and stay tuned. However, since students are a particular target group, a few months ago, several students in Amsterdam teamed up to start so-called student initiatives for open science. And now I am very happy to hand over now to the initiators of the student initiative for open science in Twente. So thanks for your attention. And now I give the floor to Prashant and Shawai.
Thank you, Marcus, to giving us the great insight of the open science. Moving towards our next agenda in the meeting, like we are going to present how we are going to initiate as a open science. So let me share my slide, please. Okay, so we are student initiative for open science. So about us, who we are. Along with Sarai and me, we are the initiator of the open science community in the open science student community in the University of Twente. We hope we are a group of students that saw the need to further spread the message and practices of open science within the student community. In that, we aim to promote information about open science within the student community, emphasizes the relevance of open science for the student, and finally, we'll try to inspire students to become as excited as we are about the open science. So what's our mission? Why we initiated this? So we aim to widely promote informations of the issue that are currently impeding the validity of current research and offer advice in what to look out for in assessing the quality of research. Furthermore, we aim to strengthen the collaborations between both students and other parties like professors, scientists, and industries. Why I'm saying the professors, scientists, and industries? Because students mostly involved with these, because for our research we mostly need data, and most of the satellite data are satellites are commercial satellites. So we need industries to promote the open science. Why we need professors and scientists? Because we need to collaborate to guide us and initiate about what we can learn and what we can reproduce as a data sets. Also, we want to make aware to the students about how open science might be able to solve issues and how students themselves can engage in open science practices. In this way, we want to strongly emphasize the student perspectives and the applicability to their lives. We also believe by promoting open science in the student at the earliest stage of their career, and we might be able to improve research practices in science in long term. Apart from that, why we need SIOS? So for that, I will ask my colleague Sarai, she can talk about further. Sure.
Hello, everyone. Yes, we're going to talk about why we need student initiative on open science. So I know for a fact that most of the ITC students who are in their first year, they're approaching to do their proposals and they're going to be doing their research. And your information needs to be reproducible and it also has to be open and reliable. So at our student initiative, we also want to help the students to get more information on how to make the research reproducible, but also to be open and to be reliable and transparent, and also where you're getting your information. As Marcus has noted, like now we have the pandemic, and some research is being done by other students, and they may not be that much of reliable or peer-reviewed information. So at least if you know how to get that information, it will actually help you. Yes. Sorry. Yes, so our expectations from you now as students, we also want you to join so that we can formulate a group that is recognized at the UT at large, that we can now help students to know more about open science, initiating it for the students, instead of it just only being for the open science community, but we're targeting the students. We want the students to know more about it, but also to be more involved in it. So for our open science, we would hope that you guys join us and we create a board of students and we can have more events that we organize, like workshops that we are educating on this, or even sometimes having a quiz night where we are doing open science and even reproducing a paper so that we can see that is that actually information which is reproducible, is it also reliable, or is it just biased information? It'll also educate you. I know that for some of us, we might not end up following into research, and we wonder why then should I invest into open science? But open science is not just for you to stop doing it after your research. It's also even when you're going into your workplace, you're going to do stuff. You need to know how to reproduce information, how to make it open, how to be transparent in all the things that you do. And this is actually very relevant in our day-to-day lives. So our future goal, we hope to expand and to get more students involved, as I've mentioned, and to also get our workshops of students so that we can have a far more wider reach in open science, but also for our students to be better researchers, because we are the future. You don't just become an academic before you actually learn to be an academic. So you have to learn all these things before you actually go in front. That's it today. If anyone has any more questions, please feel free to contact us. And if you have questions right now, please tell us and we can answer them right now. Right. Are there any questions? Oh yes, how can you join? Yes, right now we have our Gmail, our email that you can email us if you want to join. And also you can feel free to also contact us on our Twitter account that we opened. So the Twitter account is, as mentioned on the slideshow, and also I'll send it to the next email to all the students if you want it. We'll post it on our Twitter page if you want to contact us for further information. And you can also find this information on the Open Science page. We'll put our contact details and you can always email us. Any more questions?
Hi.
Yes.
My name is Marla. I'm from the Student Initiative for Open Science in Amsterdam. And first of all, I want to congratulate you for founding this initiative. It's such a good thing that it finally spreads and that other people take it on as well. And yeah, I'm really excited to have common effort there, or that we're gonna have a common effort there. And yeah, if you need us to also retweet anything about what you just mentioned, we would also be happy to do that. Or yeah, I mean, you know this already.
Yes. That's fine. Thank you so much for joining, Marla. Are there any more questions? Well, I think if there are not many more questions, you know where to find us. Our Twitter page, we have put it, and you also can email us, and you can also find more information on the Open Science page that that Marcus has also sent a link to. Thank you so much all for joining. We hope to hear from you guys.
Marcus, you want to add some words?
Oh, Marcus, do you have anything else to add if you want?
I would be maybe interested in getting some insights from the audience. So why are you actually here? So why did you join this meeting? What is your interest in open science? Maybe some of the participants would like to speak. Be very interesting to know more about it. Just feel free to unmute and speak.
Hi, I'm Iris. I'm also from the Student Initiative for Open Science in Amsterdam. I was just really excited to see the youth starting up, and I was just really wondering like what you are going to do. So yeah, it was really great, and I'm really excited to see you grow as well.
Can you maybe share some experiences? So how was your start? What were the first activities that you have done, and how did you get people engaged?
Yeah, of course. I joined SIOS a few months in when it started, so it's I think over 2 years ago now. And I started really helping out with the events mostly. We were only with 4 people when I started. We quickly went to 6, and then the year after that we had over like I don't know, like 12, or we doubled for sure. So that it was really nice to see yeah, how we grew. We had a lot of help from the open science community in Amsterdam. So it's great that you guys are working together as well. The first event I worked on was a talk by Erik Jan Wagemakers on Bayesian statistics and p-values. Yeah, so he definitely gave a great talk, and yeah, we did a lot of events that year. We did a panel discussion with PhDs from different departments within the psychology, and to see how like their departments were their how they felt about open science, and we also had a student as well. So that was really interesting, and it's been great. I've learned a lot about open science just by like talking to yeah, the other people in SIOS and talks, the guest lecturers for sure.
Okay.
And may I ask, what was your personal motivation to learn about open science?
I was well, it was 4 of my friends started open science, or classmates, so that helped. But I was also working with data from many labs, which is a really big like open project, and I was really excited because everything was open. But then I figured out like how hard it was to work with their data and their code. And then I kind of really got into thinking what goes into making data reproducible or like science reproducible. So that was kind of like my main motivation, I guess.
Okay, nice.
Yeah.
Thank you.
Of course.
I see Marla is also
Yeah,
here, and we are mostly inspired from SIOS Amsterdam. If you could share some of your ideas or so it would be great for us as well, Marla.
Yeah, actually wanted to ask you guys if you have any ideas yet for your first events or something like that. Do you have like a little plan yet?
Yeah, we are this was just initiative about the kickoff meeting, and we thought about to come get into touch with you guys and how you are organizing these all events. And currently we are just following the open kitchen science by university community, but for at the student level we also need some kind of meeting and webinar, or like how we can reproduce the data, or we can make a data hub, something like that. So
yeah, that sounds super interesting. No, I mean, I don't I'm not saying that I expect that you have already an event planned. I know how hard it is to start such an initiative. That's why I'm also, yeah. No, I was just wondering if you had thought about some first events or so. But yeah, I guess we will also meet at some other point.
we drafted some framework. If you want, I can share it with you, like what's our next step, and you can give a comment on over that, so we can just change it or not.
Yeah, that sounds good. I guess about your question, what I also like besides the events, think what also is super nice, has been super nice in the last months, was also our visits to, for instance, conferences, because we could actually talk to researchers about our plans and got a lot of support, and could, yeah, I mean, I don't know why was it nice, because it was just like, it just, I guess, felt good to exchange also and to get appreciation from non-students also for initiatives. And also you get to know a lot of, you can also network even a bit. So this is of course not the reason what to be in a student initiative, but still it's a nice incentive maybe for some other people to join. Yeah. Also, it's interesting to go to conferences. I love it.
Yeah, that's a nice suggestion. Thank you for that. Ruiz is asking about he or she, I don't know, but he already registered there in open science space. Okay, we will come to you and talk about that, because we are in the process of having a link over there who else joined the student community. So, but it's in the process. So till now we only have the piece about from the open science community Twente. So for any updates, we have to register there.
Cool.
Prashant and Sarai, may I ask you what is your personal motivation to initiate such an open science community for students?
Yeah. Sarai, you want to talk about that?
Yes. Well, I'm actually also doing, my thesis is on COVID data, and I realized that there's a huge gap right now. Like, there are a lot of papers which are saying a lot of things on data-driven modeling, but then there's not much which you can say that is peer-reviewed or is actually valid information. So to me, open science was something that actually helped me to get information that is peer-reviewed, that is reliable, that is something that I can use, and I can also reproduce my information. So I would want also students to have the opportunity to get that information, and also not for them to also use this, even if they decide to be PhD students or to be academics, at least they know what channels to do and how to make information open to everyone. Because there's that whole issue of maybe you have been writing code and your code somehow you have issues with it and you don't remember where exactly you had a problem. But if you had registered your code maybe in GitHub, you know where to trace your information. So to me, open science is actually something very crucial in your research, and you see even in your academic life after.
Adding to the point of Sarai, we are mostly working on the satellite data sets, and for example, Lancet series and Sentinel series. These series are like totally awesome, and it gained so much popularity. It's only because of the openness of the data sets, satellite data sets. Apart from that, we can see most of the satellite program are there, but still we hardly know about a lot of satellite program. But if you talk who else are working in the working with the satellite image processing, they must know about the Lancet series and the Sentinel series. So we have to learn from that perspective. So like if we are open with the data sets, we mostly get a lot of help from that.
Okay.
And as a student, we are learning day by day. So it's still need come to the platform and talk about your ideas. So if the idea is open, then only we can regrow that idea as well.
Yeah, and I think as a student, you have the opportunities and the time to try things out. So learning a new scripting language, for example, stuff like that.
Yeah.
Yeah, true. Quite true. Well, I'm sure if people have more questions, they can send us email, and they can always find us on Twitter. We're always open for suggestions, and we're always open to work with any one of you. And thank you so much, Iris and Mala, for joining us. And hopefully you can also invite us to future projects that you do. There is a question, sorry.
Yeah, Ruiz, you can.
Yes, Ruiz, can you put your mic on?
Hello, can you hear me?
Yes.
I have been attending several meetings like this one, and now I am wondering if is it possible to have examples that shows you how to run, let's say, the workflow process to reproduce, let's say, I don't know, an experiment or maybe a paper that already is open, totally open, like from the data to the code, and that we can also see, I don't know, the plots or the graph or the conclusions, let's say, during a meeting. But I don't know. I am just wondering what are the difficulties to implement this, and if actually we have an example, because I have interest to see, evidence that these already exist in papers or in publications. So I don't know if we have an example for here in ITC, or if a professor already can give us an example to PhD students about this entire workflow. But as I said before, I don't know how difficult that can be, even if it is recorded in a video. But I will enjoy it a lot to see a paper that is published that already provides links to the data, that you also can load the data in your computer, download the code from GitHub or something, and that you can actually use Control-Enter to the code, and that you see the plots. So I am just wondering if this is feasible. Maybe this is somehow like these activities that they do for carpentry, workshops or something like that. But I am just wondering how feasible it is to, let's say, to do the next step and to show evidence about open science.
Yeah, we are in the process of, thank you, Luis, for this question. Actually, we are in the process of organizing the workshop about how we can promote the open open science and data sharing as well as the code sharing. For that, like as you ask the questions, you can for the code you can always visit GitHub. That's also a nice platform. And anything else, Marcus? I think you can answer these questions now. You have
what we don't have yet is a list of reproducible workflows at ITC. So this is certainly something that will come in rather in the next years than in the next months. This is on our agenda. If you are thinking about reproducible computational workflows, you might be interested in this workflow. I will paste it into the chat. It's a workflow for R, but you can use a similar workflow also for Python. So it basically starts with a GitHub repository and it ends with a reproducible document. And this explains a bit the steps on that you need to take to achieve such a reproducible document. It's very vague and rough, but it does provide a first guidance.
Okay, thank you very much for the update about this topic. Hope to see this kind of examples in well, I don't know if in this year or in the next, but it will be really exciting to see something like this. Thank you.
Well, you can also ask your colleagues, by the way. So this is also something that I would encourage, to get in touch with your colleagues. And if you are talking about your research, then simply ask if their code and data is available and what they are doing with that. So this would be very interesting. So just talking about it. So this is also an option.
Thank you, Marcus, for answering this question. And yeah, it's really going to help everyone. I think, is there any questions from viewer? We are still open to, we still have 8 minutes. So if any question is there, it's welcomed. Otherwise, we can close the session and we can proceed and we can look into some other workshop as well. Sarah, you want to add some point? Say thank you to everyone.
Yeah, thank you so much, guys, for joining. And we hope to work with most of you. And we also hope that you join us and you give us as much questions as you would want. And hopefully we can answer all of them. And we can all work together. Thank you so much, Marcus, also for presenting for us. It was quite informative. And yes, thank you again.
And a special thanks to SIOS Amsterdam team, actually.
Yeah. All right, bye.
Bye-bye.